All right, we have four methods for solving quadratic equations. The first is called the square root method, and we use that when we do not have an x term. 2x squared plus 14 equals 70 has no x term. So we start by isolating the squared term. So we're going to subtract 14 from both sides, and 2x squared is 56. We will divide by 2. X squared is 28. So when we introduce the square root to get the x by itself, the inverse of squaring is square root, we introduce a plus or minus. So the plus or minus square root of 28 is our solution. However, 28 has a perfect square in it. We'd like to take that out. So we'll say plus or minus the square root of 4 times 7, and we get the square root of 4 is 2, so plus or minus 2 square roots of 7. A second method is called factoring, and so that can be used when you have an x squared term, a bx term, and a c. So in our first situation, we have an x squared plus a 2x and a minus 48 equals 0. There are lots of things that multiply to 48, but 0 is special. You must have it in standard form with everything on one side. So we ask ourselves, what are factors of x squared? Well, x times x gets us x squared. And factors of 48 that can, negative 48, that can subtract to become a positive 2 are, well, we have 48 times 1, 24 times 2, 6 times 4. 6 times 4 can subtract to become a positive 2. So we need a positive 6 and a negative 4. So our first factor is x plus 6. That's got to be equal to 0, or x minus 4 is equal to 0. If x plus 6 equals 0, x is a negative 6. If x minus 4 equals 0, x is a positive 4. When we have a leading coefficient, a number other than 1 in front of the x squared, there are a couple of methods to work with this. You can either guess and check by putting 3x times x in as your first terms, or you can multiply the a times the c. 3 times a negative 10 gives us a negative 30. And so we want factors of negative 30 that can subtract to become a negative 13. 10 times 3 would add to become 13, but it would not to subtract to become 13. So we need 15 and 2. We want a negative 15 and a positive 2. So we rewrite our 3x squared, our first term. We write a negative 15x, a positive 2x, and we drop our negative 10, our constant. Then we group. The first two terms have a 3x in common. We're left with x minus 5. The second two terms have a 2 in common. When we factor the 2 out, we're left with an x minus 5. We are successful because we see the x minus 5 as one of our terms, and the remaining is the other term, 3x plus 2. Both terms set equal to 0 gives us a 3x plus 2 equal to 0. Subtract 2 from both sides, 3x is a negative 2, so x becomes a negative 2/3, or if x minus 5 equals 0, then x has to be a positive 5. A third method is called completing the square. To complete the square, you want to take the constant to the other side of the equation. So we keep the x squared and the 30x together, but we take the 104 to the other side. Adding a negative 104 gives us a 0 pair, so we'll have a negative 104 on the right hand side. Now we ask ourselves, what is half of 30? Half of 30 is 15. 15 squared is going to get us 225. So if we add 225 to the left side of the equation, we have to add 225 to the right. When we do that, we have made a perfect square trinomial. If we factor this, we get x times x plus 15 plus 15, so it's x plus 15 squared. That's equal to 121. 225 minus 104 is 121. Now, when we introduce the square root to solve this, we take the square root of both sides. The square root of something squared is itself. And when we introduce the square root, we introduce a plus or minus, so plus or minus 11. Now we subtract 15 from both sides. So if x is equal to a positive 11 minus 15, we get an answer. And if x is equal to a negative 11 minus 15, we get our second answer. 11 minus 15 is negative 4. A negative 11 minus 15, they're both negative. We add them up and give them a negative sign, so negative 26. Those are our two values for x. And finally, when we can't factor or we don't want to complete the square, we always have the option of using the quadratic formula. We always need to start with the equation in standard form. 3x squared plus 4x minus 10 equals 0 gives us an a that is 3, a b that is 4, and our constant term is the negative 10, that's our c. So we plug it into the quadratic formula. X is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So an opposite of 4, a negative 4 plus or minus the square root of 16. 4 times 3 is 12, times 10 is 120, and a negative times a negative is positive. 120 and 16 is going to get us 136. So negative 4 plus or minus the square root of 136 over 6. 136 is even, so we try dividing it by 4 to see if there's a perfect square in there, and there is. Negative 4 plus or minus the square root of 4 times 34 over 6. If we factor the 4, or take the square root of 4, we'll bring it out, and we'll have a negative 4 plus or minus 2 square roots of 34. The square root of 4 is 2. And because all are even, we can factor that 2 out of each term in the numerator, or think of it as splitting it into two separate fractions. Negative 4 sixths becomes a negative 2/3, and a plus or minus 2 over 6 simplifies to 1 over 3, so we've got the square root of 34 over 3, which could also be written as negative 2 plus or minus the square root of 34 over that common denominator of 3.